The last chapter covered by our subject is Chapter 20, Managing Operations, Quality, and Productivity. These are the learning objectives. By the end of this chapter, you should be able to describe the nature of operations management, discuss the components involved in designing effective operations systems, discuss organizational technologies and their role in operations management. Identify the components involved in implementing operation systems through supply chain management. Explain the meaning and importance of managing quality and total quality management. And explain the meaning and importance of managing productivity, productivity trends, and ways to improve productivity. Operations management is the total set of managerial activities used by an organization to transform resource inputs into products, services, or both. The importance of operations. Competitiveness, overall organizational performance, quality, and productivity can all be enhanced through efficient and effective management of operations. In a manufacturing environment, operations management provides form utility by combining many dissimilar inputs to create an output. In a service organization, operations management creates value by providing time and place utility. Manufacturing is a form of business that combines and transforms resource inputs into tangible outcomes. Examples: cars, technology tools, clothing, furniture. Cars would be a combination of tires, engine, body, seats, and seat covers, and all the other parts that would make up the finished product, which is the car. Similarly, clothing is made up of inputs like fabric, buttons, thread, zipper, garter, and other parts that would make up the finished product. Service organization is one that transforms resources into an intangible output and creates time or place utility for its customers. Service is intangible. You cannot see it before it is utilized or consumed. For example, a hairstylist have input materials like scissors, comb, brush, hair dryer, including the skills to do the haircut. You cannot see the haircut or the act of the haircut not until it is being performed. You may see pictures of a finished haircut, but the picture is not the product. The product is the service, which is the act of cutting the hair. Operations management directly impacts the organization because it determines the overall effectiveness of the organization. Operations management has a direct impact on competitiveness, quality, productivity, and effectiveness. Operations management and organizational strategy have reciprocal effects on each other. Strategic goals cannot be met if there are deficiencies and insufficiencies in operations resources. Determining product-service mix refers to how many and what kinds of products or services or both to offer. Managers must choose the appropriate capacity of the firm, which refers to the amount of products, services, or both that can be produced by the business. The capacity decision is truly a high-risk one because of the uncertainties of future product demand. If demand is overestimated, the resources, which are the capital investment required to build the facility, may never be recovered. And if underestimated, market opportunities may be lost. Facilities are the physical locations where products or services are created, stored, and distributed. The organization's location is its physical position or the geographic site of facilities. Location is determined by what amenities, like example railroads, airports, etc., or customers like mall shoppers, downtown shoppers, which must be near to the facility, as well as what coincides with its organizational strategy. Layout is the choice of the physical configuration of the facilities, the arrangement of equipment within the facilities, or both. Product layout is a physical configuration of facilities arranged around the product. This is used when large quantities of a single product are needed. Process layouts, a physical configuration of facilities arranged around the process, used in facilities that create or process a variety of products. Fixed position layout is a physical configuration of facilities arranged around a single work area, used for the manufacture of large and complex products. Cellular layouts, a physical configuration of facilities used when families of products can follow similar flow paths. Watch this video about facilities decisions.
Organizing the layout of a facility is important to ensure the most efficient methods of creating, distributing, and storing products or services. There are three types of facilities layouts: product, process, and fixed position layouts. Most assembly lines use a product layout. Specific tasks are performed at each workstation as each unit flows past in a straight line, as seen in the production of cars or computers. Process layouts are used when a variety of special products or resources are needed. The work is moved from one station to another. For example, a heart attack patient in a hospital may be moved from the emergency room to cardiology to intensive care. A fixed position layout is used for creating a very few large and complex products, such as airplanes or ships. The product remains stationary, and the people and machines move around it as they assemble it. The best facility layout depends on the product or service needed in the organization.
Manufacturing technology. Technology is the set of processes and systems used by organizations to convert resources into products or services. Automation is the process of designing work so that it can be completely or almost completely performed by machines. Because automated machines operate quickly and make few errors, they increase the amount of work that can be done. Automation relies on feedback, information, sensors, and a control system. The impact of automation on workers is complex. In the short term, workers whose jobs are automated may lose their jobs. In the long run, however, more jobs are actually created than lost. Robotics refers to the science and technology of the construction, maintenance, and use of robots. A robot is any artificial device that is able to perform functions ordinarily thought to be appropriate for human beings. The use of industrial robots has steadily increased since the 1980s and is expected to continue to increase slowly as more companies recognize the benefits that accrue to users of industrial robots. Applications that use robots include welding, materials building, machine loading and unloading, painting and finishing, assembly, machining applications such as cutting, grinding, polishing, and drilling, and inspection work. Service technology are rapidly moving toward automated systems and procedures. Examples of automation in the service industry include automatic teller machines or ATMs used by banks, patient information system used by hospitals to track patients, self-check lanes used by grocery stores, and computerized reservation systems used by hotels and airports. Computer-assisted manufacturing is technology that relies on computers to design or manufacture products. Computer-aided design involves using computers to design parts, complete products, and simulate performance so that prototypes need not be constructed. Computer-aided manufacturing is a use of computers that ensures that design moves smoothly to production and is usually used in combination with computer-aided design. Computer integrated manufacturing or CIM allows for coordination among all manufacturing activities, linking computer-aided design and computer-assisted manufacturing systems. Flexible manufacturing system or FMS, the use of robotic systems and computers to coordinate and integrate automated production and materials handling facilities. They usually have robotic work units or workstations, assembly lines, and robotic carts or some other forms of computer-controlled transport system to move material as needed from one part of the system to another. Operations management as control can be obtained by coordinating it with other functions to help ensure the system focuses on the elements crucial to goal attainment. Depending on the strategic role of operations, managers are accountable for different kinds of results. Supply chain management is the process of managing operations control, resource acquisition and purchasing, and inventory so as to improve overall efficiency and effectiveness. Learn more about supply chain examples in manufacturing and services in this video.
What is a supply chain? A supply chain is a global network used to deliver products and services, from raw materials to end customers, through an engineered flow of information, physical distribution, and cash. Basic supply chain for a product. The below figure illustrates a very basic supply chain with three entities, a producer with one supplier and one customer. Four basic flows that connect the supply chain entities together are as follows. Flow of physical materials and services from suppliers to the end customer. Flow of cash from the customer to the raw materials supplier. Flow of information back and forth along the chain. And reverse flow of product returned. A basic supply chain in this figure is made up of these entities. Seller is a supplier who provides goods and services, or a person or organization with whom the buyer does business. Their generic term in marketplace is seller. Supplier provides materials, energy, services, or components for a product or service, such as plastic, fabric, electric wiring, or aircraft. A producer is the one who receives components from the seller to produce a finished good or service, such as shirts from fabric, crockery from plastic, power from electric wiring, or provides transportation through aircraft. The customer is the one who receives the finished product. That is the one who wears those shirts, uses the crockery, turns on the lights, or flies in an aeroplane. Supply chain example. Consider a supply chain model of a bakery who sells a variety of cakes, and this baker is one end of a supply chain. In this case, a supplier is a wholesale food distributor that provides ingredients such as flour, cream, and sugar. The bakery is the producer who turns those ingredients into a variety of cakes. The bakery is operated by an owner who is the retailer and who sells these cakes to the customer. Supply chain in manufacturing. Consider a complex manufacturing supply chain model that appears in corporate supply chains. In this model, you will notice the second tier of suppliers and more distribution centers and customers. These suppliers supply materials as well as services. You put the manufacturing at the center and suppliers of components to the immediate left. The Tier 1 suppliers have their own suppliers in Tier 2. For example, Tier 1 supplier might be a wholesale food distributor that purchases flour from its own supplier. This supply chain for flour starts from farmer's wheat field, which is supplied to the food distributor, processed in a plant, shipped to wholesalers, and distributed to the stores. No matter how far you travel toward the left, you will never run out of new tiers of suppliers. Primary product flows from left to right, and primary cash flows from right to left. Supply chain in services. Initially, the supply chain model was developed for manufacturing, but service industry has supply chains too. A few examples of services industries are electricity provider, legal advisor, real estate, construction, software house, and even federal government. In its broadest sense, service industries include all organizations except farming, mining, and manufacturing. Below exhibit illustrates the supply chain of an electric utility. It receives products, services, and supplies, and dispenses its services to home customers, commercial customers, and to other utilities.
Purchasing and inventory management. Purchasing management or procurement is concerned with buying the materials and resources needed to produce products and services. The manager responsible for purchasing must balance a number of constraints. Buying too much ties up capital and increases storage cost, whereas buying too little might lead to shortages and high reordering costs. The manager must also make sure that the quality of what is purchased meets the organization's needs, that the supplier is reliable, and that the best financial terms are negotiated. Many organizations have recently changed their approaches to purchasing as a means to lower cost and improve quality and productivity. In particular, rather than relying on hundreds or even thousands of suppliers, many companies are reducing their number of suppliers and negotiating special production deliveries arrangements. Inventory control manages the organization's raw materials, work in process, finished goods, and products in transit. Each type of inventory is managed by different methods for different purposes and has a different source of control. A recent breakthrough in inventory management is the just-in-time method that has necessary materials arriving as soon as they are needed or just in time so that the production process is not interrupted. In addition, smoothing the production schedule, the JIT system reduces the organization's investment in storage space for raw materials. It allows for savings of unnecessary rental for warehouse spaces. Materials that are not yet needed for processing are not yet scheduled to be delivered so that it will not take up unnecessary warehouse space. The meaning of quality. Quality is the totality of features and characteristics of a product or service that bear on its ability to satisfy stated or implied needs. Quality is both a relative and an absolute concept. Quality is relevant to both products and services. The difference in quality is based in design and other features. There are 8 dimensions that determine product quality. Performance. It is a product's primary operating characteristic. Example, automobile acceleration and a television picture clarity. Features. Supplements to a product's basic functioning characteristics. For example, power windows on a car. Reliability is a probability of not malfunctioning during a specified period. Conformance is the degree to which a product's design and operating characteristics meet established standards. Durability is a measure of the life of the product. Serviceability is the speed and ease of repair in case of damages. Aesthetics is how a product looks, feels, tastes, and smells. And number 8 is perceived quality. This is the quality as seen by a customer. Quality is an important concern for managers and organizations for 3 very specific reasons. First, competition. Quality has become one of the most competitive points in business today. Next is productivity. Managers have come to recognize that quality and productivity are related. In the past, many managers thought they could increase output only by decreasing quality. Managers today, however, have learned that such an assumption is almost always wrong. Next is cost. Improved quality can lower cost with fewer returns from customers due to defects or less maintenance and fewer customer complaints. Total Quality Management, or TQM, or sometimes called quality assurance, is a strategic commitment by top management to change its whole approach to business in order to make quality a guiding factor in everything the organization does. There are 5 basic dimensions of TQM. Strategic commitment. A strategic commitment from top management is the starting point for TQM. Such commitment is important for several reasons. The organizational culture must change to recognize that quality is not just an ideal but also an objective goal that must be pursued. Another reason, a decision to pursue the goal of quality carries with it some real cost for expenditures such as new equipment and facilities. Thus, without a commitment from top management, quality improvement will prove to be just a slogan or just a gimmick, and will with little or no real change. Employee involvement is also important. The person responsible for doing the job should also be responsible for making sure that it is done right. Work teams are a popular approach to increasing employee involvement. Improving quality of materials used to produce products is a powerful tool for improving total quality. New forms of technology, such as robotics and automation, can improve quality. Improving the methods and operating system used by the organization during the actual transformation process can also have a strong impact on quality. TQM tools and techniques that the organization can apply include value-added analysis, which is the comprehensive evaluation of all work activities, material flows, and paperwork to determine the value that they add for customers. The analysis can reveal wasteful or unnecessary activities that can safely be eliminated. Benchmarking is the process of learning how other firms do things in an exceptionally high quality manner. The firm can model these practices and use what is applicable to the organization. Outsourcing involves subcontracting services and operations to other firms that can perform them cheaper or better. If a business performs each and every one of its administrative and business services and operations, it is almost certain to be doing at least some of them in an inefficient or low quality manner. If those areas can be identified and outsourced, the firm will save money and realize a higher quality service or operation. Reducing cycle time is a way of getting activities performed more quickly. Cycle time refers to the time needed by the organization to develop, make, and distribute products or services. If a business can reduce its cycle time, quality will often improve. ISO 9000 or 2000 and ISO 14000 are sets of quality standards created by the International Organization for Standardization. ISO 9000 2000 standard focuses on quality issues, whereas ISO 14000 focuses on environmental performance. By meeting ISO standards or by requiring its suppliers to meet the standards, a firm can improve quality. Statistical quality control includes several statistical techniques that can be used to monitor quality in organizations. Especially useful are acceptance sampling and in-process sampling. When you say acceptance sampling, it involves sampling finished goods to ensure that quality standards have been met. In-process sampling involves evaluating products during production so that needed changes can be made. Six Sigma refers to the goal of having only 3.4 defects per million units. It involves making connections or corrections to production processes until errors virtually disappear. Productivity is an economic measure of efficiency that summarizes what is produced relative to resources used to produce it. Levels of productivity are the units of analysis used to calculate or define productivity. These are aggregate productivity, which is the total level of productivity achieved by a country. Industry productivity is the total productivity achieved by all the firms in a particular industry. Company productivity is an individual company's productivity. Unit productivity is the achievement of a unit or department within an organization. Individual productivity is the productivity level attained by a single person. Forms of productivity. Total factor productivity is a ratio of outputs to inputs. It serves as an overall indicator of how well an organization uses all of its resources to create its products and services, meaning labor, capital, materials, and energy, to create all of its products and services. Labor productivity is a partial productivity ratio, which uses only one category of resource. Here is labor instead of all of them. This helps to gauge the organization's productivity in utilizing that resource. Productivity is important because it determines the organization's ability to survive and also because it practically determines people's standard of living within a particular country. The present shows that manufacturing productivity growth continues to exceed that of the service sector. Improving productivity by improving operations. One way to improve productivity is by improving operations. This may involve spending more resources on research and development to identify new products, new uses for existing products, and new methods for making products. It can also involve reassessing and revamping transformation facilities such as plants and equipments. Increasing employee involvement. The other major thrust in productivity enhancement is by increasing employee involvement and participation. Making the organization's workforce more flexible includes cross-training workers to perform a number of different jobs. However, it is important that rewards be provided to make employees' involvement really work. Chapter summary. Now that the lesson has ended, you will have learned how to describe the nature of operations management, discuss the components involved in designing effective operation systems, discuss organizational technologies and their role in operations management, identify the companies involved in implementing operation systems through supply chain management, explain the meaning and importance of managing quality and total quality management, and explain the meaning and importance of managing productivity, productivity trends, and ways to improve productivity. You have reached the end of the chapter.